Hello, everyone. Whoa, so many faces. It's great to welcome you on the 60th WarsawJS Meetup. Today I will be talking about testing observables. My name is Chris, and let's just get started. So, first of all, I would like to start from some basic concepts. So, why do we actually test our code? First of all, it gives us confidence that what we did right is actually doing what we wanted to. And the next step coming from that is that we can maintain our code better. So if we want to refactor it, we won't be afraid to do so. So if anyone here ever was afraid to touch some code, it might have been because it wasn't tested well enough. So testing can prevent that. And the next thing that if you work with test-driven development, it acts as a guide for you. So you write test first, and then this kind of gives you how your code should behave, and you can fail and pass the tests you write over and over again. And the final thing is that it is basically a documentation of your code. So the next developer will know what actually your code does, and it's kind of a smallest example of how you can use it in other parts of your application. So we've got why covered. So let's go straight away to how do we test. So with the I will start with the most simple example I can imagine. So a multiply function. If for some reason we want to test that, we can do that. And we can choose a lot of testing frameworks. Most of them will have syntax similar to this. So we provide a test suite with the describe wrapper, and then we put individual tests in the it function. So our multiply function should calculate properly. So how do we test that? We provide it with the input and expected output, and then calculate, run our function with the input and compare if the result is equal to the expected value. And in this case, it passes, so we are happy. And can we test observables the same way? So I created a small example with the not null operator. So if you have an observable, a stream of data, it will only emit, after applying this operator, it should only emit values that are not null. So it will basically filter null values. So let's test that quickly with the same approach as we did with the multiply function. So we create our source. From is just a helper function to create an observable from an array. Then we create our result observable with not null applied to it. And then to test what comes out of our result, we create a spy function. And because observables are lazy, we need to actually subscribe to check what's happening underneath. So we subscribe to our result, and we expect the spy to be called 2 times because the null should be filtered out, and to have been called with 1 and 2. So this works, exactly this test. And so are we done? Well, that would be cool, but not really. So let's come back to what observable actually is. So this is a diagram representing that, and how I like to think of it is that it's data delivered over time, And that part over time is really important because it can be synchronous. And in the example I have shown you, it actually was. But most of the time it won't be, and it will be asynchronous. So we need a way to test the asynchronous behavior of it. So let's write a second test, similar to the previous one, but the difference is that by default, from will emit all the values right away because it's synchronous. But we can provide it with a different scheduler, which will basically schedule it for the next tick. So it will basically run it asynchronously. And the rest of the code is the same. And in this case, the test fails. So what happened is actually that when we subscribed, no value was emitted yet, so our spy didn't actually get called at all. So we need a way to work around that. So the first way to do so is pretty similar to what we used to do with testing promises. So the difference here in this scaffolding is that we have a whoa, that's wrong. This only this done should be here. Sorry. So we've got a done function here, which will notify the test runner that our test is finished. So first 3 lines are the same. So we have our source with 1, null, and 2, and we've got a result which filters out null values. And we create a spy as we already did. And now we need to subscribe a bit differently. So the previous syntax was a shorthand for just calling next function, which basically is called when we emit new values. But now we actually want to know when our observable is complete. So when it emits all the values, it will emit another event called complete, and when it happens, this function will be called. So we can move our logic from the synchronous example to this one just inside of this function. So let's do that. Now we expect after the result is complete, we expect it to be called twice with value 1 and 2. And now we can call our done function, which will notify the test runner that we are done. So this test passes. So yay, we are happy. But what are the pitfalls of this approach? So well, we need to be aware of the when the observables is complete, and some of the observables are never completing, so we kind of need to work around that, and it might be hard to do so. Secondly, the test can take long. So imagine that our test wasn't just taking one tick to execute, it would be delayed for a few seconds. It will take those 3 seconds to execute. So and even test runners by default have a limit of 5 seconds after which it will time out. So it's kind of not, we don't want that behavior to be there. And this is the example of the delayed source. And in this case, the previous test will take 3 seconds and few milliseconds. So if we have multiple of those running, it will probably prevent us from running those tests all the time, which might cause us more bugs, more fixing in the future. So how can we handle that more neatly? We can use fake asynchronous tests. So how do we do that? So what's happening? Sorry, I forgot to. Okay. we need to wrap it with the fake async function, but it's not shown here. But apart from that, it's a good example. So the first lines are the same, and then we just subscribe with our spy. And now we can just use a tick function, which will basically mimic the behavior of time passing. So at first, we expect it to not have been called because it's delayed. But after 3,000 milliseconds, which we pass with the tick function, we expect it to be called with again twice and with the values provided. So again, it passes. And what are the benefits of fake async tests is that they are synchronous. So we don't have we can manage how the time passes more easily and test what happens after that. And we have full control over time. So the test will actually run just 50 milliseconds or something like that. And so it's fast. So we don't have a downside of waiting 3 seconds for it to execute. But we have a nicer way to test observables. There is a library for doing so, which is called, the concept is called marble testing. And the diagram I've shown you before with the stream of values was basically a visual representation of our stream. And with marble testing, we kind of doing the same, but in our IDE. So it has a visual representation in the tests themselves. It's more intuitive because we can look at the observables and visualize how it works. It's fast, just as fake async was. So let's have a look how we can apply that. So the only difference, the one difference is that we need to wrap our testing function with the marbles wrapper, which provides us with the marble testing context, which will allow us to create and assert observables. Can I have some water? Okay. So this is the part where which I talked about, that we can kind of see how our observables look like. So here we define our source observable, which will contain X, Y, and Z, which will map to 1, null, and 2, as we had in our previous example. And the expected result is just 1 and 2 at the time specified by the visual representation. So if the source had a value at this time, we expect it to occur at the same time in our result. And then we, with the context, we can create our observables by calling called. The difference between cold and hot observable is well explained by my friend Natalia Tepluchina. If you are interested, I can direct you afterwards. So here we create our source and our expected results. And because here we used X, Y, Z, we need to actually provide a mapping for what those stand for. So here X stands for 1, Y stands for null, and Z stands for 2. And then we just create our result as we already did before. And now we can use another function from our context, which is expect. And then we just expect result to be the expected observable. And that's basically checks when everything happens, if all the values are emitted at the same time, if they are the same, if they are completed at the same time, etc., etc. And this test basically passes. So I think I have some time for some more examples. So let's go to our visuals to our web store. So here I have and maybe I will start with the marble testing example first. So we have our is it I don't know, not this way. Is it big enough? Okay.
Maybe try black text on white background.
Ooh. Color scheme. Default. No. Okay. Is it better? Okay, so we have our source, which emits 1, 2, 3, and 4. And I have created a buffer delay function, which basically what I wanted to do to maybe it will be easier to write what is expected. So we expected it to have emit 1 right away, then wait 5 milliseconds to emit the next value, 1, 2, 3, 4, 5, and then emit wait another 5 milliseconds to emit 3, and then wait another 5 milliseconds to emit 4. So it kind of spreads the emitted value. It acts like a dam. So whenever we can, for example, click the button how often we want, but it will emit all the clicks at some point, but they will be spread evenly by the time we specify here. So, and then we expect it to end. I did wrap it with, because those will happen at the same time. So we will emit the 4th value and finish right away, because this stream already have finished. If we made it a bit longer, we could expect it to be like this. So we can start with that. And it should fail. That's the beauty of live coding. How do I come back? Buffer, lay spec. Maybe I should try. Haha. Okay, I didn't write any assertions. Yes. Okay, so now we just expect our result to be observable expected. Please fail. Yeah. Okay. So our code failed, and now we can switch the implementation to the one that is actually working. And okay, it works. But let's imagine that we want it to work a bit differently. So we had our end complete here, and we want to, if our source observable completes, we want our result to complete right away. So this is our expected behavior. Fails again, yay. So this kind of helps us model our behavior. So we can visualize how it works, and this helps both us as developers writing the code and the future. Maybe our children will have a look at our code and not blame us for being douchebags. So let's fix that. Const done. New subject. So now we can work in the test-driven development way and try to fix our failed code. So we just need to make sure that when our source actually emits a complete, we want it to be finished. So let's make sure that that happens. We have a operator for calling a function when the observable completes, which is called finalize, and we just push to our done. Okay. So what happens is that whenever our source is complete, we push to another observable, which is called done. And then our whole observable is take until operator is applied to it, so it will make sure that it ends at that time. So now our code is successful. So I don't know if I have still 5 more minutes. Maybe yes, I didn't hear the bell. So let's go back to our spec. So we can write similar stuff in our previous ways, but because we just change the behavior, it will basically act as it completes right away, because this is just a synchronous stream. So it will emit 4 values and complete right away. So let's go back to our previous implementation. This is enough to just comment this out. And how can we do that with our fake async way? So let's focus here. This is done. Okay, this should pass because there's no assertions. But we can create our spy, const spy, create spy. And as we did before, we just subscribe to our result with a spy. And then, because this was emitted right away, so we expect it to be called right away. So expect spy to have been called once. Again? Okay. No worries. To have been called, yep. And expect actually there is a better way. So const, we just save current value, and not const but let. No vars, please. Okay, so now we can just expect our current value. Okay, I have 5 minutes, I can make it. To equal 1. Then we can, so let's see that it still passes. Okay, it passes. Ooh, it doesn't pass. Awesome.
You have 5 minutes on make it fast. You can do it.
La 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 la. Awesome. Yeah, that's useful. There's, okay. We just need to make sure that we flash everything. So let's just, okay. And what? Not here. Here. Okay. Okay, we needed we had to make sure that our result stream is finished. So we just make sure with the with tick to actually 4 seconds would be enough. But so we expect the value to equal 1. Then we can tick, damn it, tick 1000 milliseconds and expect our current value to equal 2. And let's duplicate that twice. 3, 4. And it still passes. If we expected it to be 5 here, it will, of course, fail. So let's go to the final one. So here we actually need to provide some kind of helper observable to help us test what happens on the way. So I call it timer equals timer. I think I cannot call it timer. It will timer 5000. So it will emit first time after 5 milliseconds, and then emit every 1 second. And we just want it to be called 4 times, because it will work indefinitely by default. And then we create our current value. We create our subscription, and then we subscribe to our timer. Subscribe with the next. Here we can do some assertions, and on complete, how long do I have? Done. I think that's all. So for more examples, you can ask me later. To summarize, we learned that observables can be both sync and asynchronous. There are 3 ways to test them: async with done function, fake async when we manually control time, and marble testing, which is more visual. Thank you for your attention. If you have any questions, I think we don't have time for them.